Hello, everyone, and welcome back. Here we are, 6v1. So we are now in this lesson talking about the derivatives of inverse trig functions. So recall a few things before we start, because we're going at a quick pace. I want to make sure I try to slow down as much as I can in this crazy environment. So recall that what we did last week is we now added to our arsenal the derivative of exponential functions, which is the natural log of a times a to the x. Okay. Now, not that that's related to it, but it's important you know where we're coming from. And then you also learned implicit differentiation. So recall that we then learned implicit differentiation, which, how does that work? The idea there is, say I gave a quick example of x times y, and I say, what's the derivative of this with respect to x? Well, you would do the product rule. So you'd say the first times the derivative of the second. But what's the derivative of y with respect to x? Well, we don't know what it is. So we write dy dx. And that's the implicit part of this. You're just taking you're differentiating, but you're not needing to get y by itself first. You can just differentiate the entire equation or expression. And when you don't know what the derivative is, or if you're taking the derivative with respect of a variable that's not the same as the variable that you're analyzing its change, then you can't do anything about it. You just write it in its form, dy dx. So it'd be the first times the derivative of the second plus the second times the derivative of first, which we know the derivative of x with respect to x is 1. Now, a little side note, you could write this as dx d over dx, the derivative of x with respect to dx. Now notice what's dx over dx? Anything divided by itself is 1. It's another way to understand it. So we never write that. We usually just write what it is. But with a different variable like y, we can't just cross out so it becomes dy dx. So that's what we have. Now, before we talk about inverse trigs, you might have forgot what that is, so let's recall what the trig functions are. So let's also recall there are 6 trig functions. And that is sine, cosine, tangent of an angle, that's theta. And then you also have cosecant theta, secant theta, and cotangent theta, which are, how are those related to this? Remember that these are reciprocal trig functions. And what I mean by that is, remember that cosecant is 1 over sine of theta. Secant is equivalent to 1 over cosine of theta. And cotangent is 1 over tangent theta. Okay. So the reciprocals. Not quite the same thing as inverse. Inverse is different. Inverse is the idea the inverse of a function allows it so they more or less cancel each other out. A reciprocal doesn't cancel out. It's more so the numerator and denominator, because these are numbers, would go to 1, because it's a number divided by itself in a way. So what are your inverse trigs? Which is what this will be about. What are your 6 inverse trig functions? Now, what's an inverse again? So I talked about this a little bit with some of the students in person last week, and might as well fill everyone in. So an inverse function. So the additive or subtractive inverse is what number do you add that doesn't change the value, and that's the number 0. So in addition, subtraction, 0 is the additive inverse. Multiplication, division, what do you multiply by or divide by that doesn't change the number, and that's 1. And then we talk about the inverse of, now this is what we learned last week, is the inverse of an exponential, a to the x, is the log of the function, or if you're using e, the natural log of the function. Right? And these are inverses of each other. So what's the inverse of a trig function again? So what's the inverse of sine? The inverse of sine you could write as sine to the -1 of x. So you might write y equals sine -1 of x. Or that's equivalent to saying, or that's what they all are. But the problem is the -1 is very common for inverse. You could say that for all of them. Like the inverse, in other words, if we want to use the inverse, we want to call something an inverse, we typically denote it with the -1. Careful here, though, that that's not the same as the power rule. That is not the same as, it's not the same as y equals sine of x to the -1. So that's not the same thing, because then you might interpret this as 1 over sine of x, which is cosecant x, and that, again, is the reciprocal. So when we talk about sine to the -1, it is not the same as that. It doesn't, the understanding of negative exponents doesn't work with trig functions, okay? So the inverse is sine inverse of x, but we don't want to call it sine inverse, so what we actually call it is, there's a better name for it, and that is arc sine of x. So this is the same as sine inverse, right? But it's an actual name, so you're not always saying inverse, inverse, inverse. So the inverse of cosine would be arc cosine of x. The inverse of tangent would be arc tangent of x. And then you have y equals arc tangent, arc cosecant of x, arc cosecant of x, and y equals arc cotangent of x. These are your inverse functions. Is the idea that it's the arc, or you might see the -1. Okay, it's the -1 or that word arc with it. Now, a little quick connection is, if you look at your calculator. Now, if you remember me saying that the inverse of e is natural log, well, if you look on your calculator, e and natural log are the same button. And calculators do that so they keep inverses together. The inverse of natural log is e, and vice versa. Look right above it. What's the inverse of 10 to the x of that exponential? Well, that's log, and then it's like log 10. If you look at x squared, what's with x squared? Square root, because what's the inverse of x squared? Square root. And then notice right above sine, what's the inverse of sine? Sine inverse. It'd be nice if they wrote arc sine, I'll be honest, but that's okay. Inverse of cosine is cosine inverse, inverse of tangent is tangent inverse. So I'm looking in blue there. So the same button is always linked to its inverse function as well. Little tidbit on how calculators are built. All right, now to the main point. So we have all that. And just remember that reciprocals are not the same as inverses. All right, so sine to the -1, which is the inverse, is not the same as cosecant. That's a reciprocal. Reciprocal. Okay. Now, let's start looking at the main point of this, which is the derivatives of these. So example 1, let's take the derivative. What's the derivative of y equals sine inverse of x? Okay. So what you would try to do is, we know how to do implicit differentiation or even derivative because y is by itself. So you would say dy dx is equal to, now what's the derivative of sine inverse? Well, we don't know this yet. That's what I'm going to show you in this lesson, what you're going to learn. You don't know yet. You'll learn that soon. So we can't just go straight to the derivative. We have to build up to it. So how do we do it? So let's make a right triangle. Okay. Now, y equals sine inverse of x. Now, what can we do is, if we wanted to get rid of this sine inverse, we can use its inverse function, which is sine. So we can sine both sides. So we take the sine of the left side, and we take the sine of the right side. By doing that, we're going to have the sine of y is equal to, and sine inverse, being that they're inverse functions, will cancel each other out, and you'll just be left with x. So what we're having here is, in a right triangle, we have that the sine of an angle y is equal to x. Now remember, sine is opposite over hypotenuse. I could write that as x over 1. So it's opposite over hypotenuse. So then it would be x over 1. if we're labeling the lengths of this triangle. Now, by Pythagorean's theorem, remember that this right here would be, if I call this b temporarily, it would be x squared plus b squared equals 1 squared, which implies that b is equal to the square root of 1 minus x squared. So this right here, this length, I'm going to write as the square root of 1 minus x squared. Okay. So with this triangle, we can help get the derivative. So when we write this sine of y equals x of 1, we're going to take the derivative implicitly of this function. Okay, so to do implicit differentiation, so this is the implicit differentiation part. It's the derivative of sine, which is cosine of y, leaving the inside alone, times y, times the derivative of the inside, which is times dy dx. Equals, and the derivative of x with respect to x is 1. Good. Solving for dy dx, we get dy dx is equal to 1 over cosine of y. Okay. Now, what is cosine of y? If you look at your triangle, cosine of y is adjacent over hypotenuse. So then that is square root of 1 minus x squared over 1. And that's hard to see. Let me zoom in a little bit. I'm trying to squeeze it on this paper when I know I don't really have the space. So what you end up getting here is, I'm going to write it up here, 1 over 1 won't matter, so it's just the square root of 1 minus x squared, because that's the cosine of y. And there you have it. This right here is the derivative of arc sine of x, or the inverse sine of x. Let's look at the next one. Let's see how this works. That paper for a second. All right, so I'm going to push this up. I'm going to resume, and I'll write bigger because I want to be able to fit more on the screen. All right, let's look at example 2. Let's look at y equals the cosine, the inverse of cosine. Now, again, I could write that as arc cosine. That is the actual name of the inverse. Okay, so we take the derivative of this. Now, in order to take the derivative of this function, you don't know it yet, so we're going to use the right triangles, and then once you have it, you won't have to do all this work unless you want to. So we don't know what that is, so we'll have to do it the old-fashioned way, which make a right triangle, and then if we have y equals cosine inverse of x, we're going to cosine both sides to cancel out the cosine inverse and write this as cosine of y equals x, which then means in a right triangle, a cosine of an angle y will equal x, which is adjacent over hypotenuse. Remember, x is x over 1. And then by Pythagorean's theorem, this side would be the square root of 1 minus x squared. So what do we have next then is we're going to take the derivative of cosine of y equals x implicitly. And you're going to have the derivative of the outside, which is negative sine, leaving the inside alone, times the derivative of the inside, which will be dy dx, is equal to 1, which implies that dy dx is equal to negative 1 over sine of y, which is equal to negative 1 over, and the sine of y, if you look at your triangle, is opposite over hypotenuse, so then that's just going to be square root of 1 minus x squared. And yeah, you could put that over 1. I'm not going to because it won't matter. And there's your derivative of the inverse of cosine, arc cosine. Good. Now, let's do 2 more, and then I'll talk to you a little bit about where I want you guys at by the end of this lesson. Example 3, what if we look at the inverse of tangent? Okay. So that's going to be, I'm going to tan both sides and you'll get tangent of y is equal to x. So in a right triangle, we have that an angle y, the opposite over the adjacent, is going to equal x, which by Pythagorean's theorem, then we know that this side would be 1 plus x squared. So then if we take the derivative of this function, tan of y equals x, we'll have the derivative outside, leaving the inside alone, times the derivative of the inside is equal to 1. And then solving for dy dx, we'd have that the derivative of this function is going to equal 1 over secant squared of y. Which I don't know if you've caught on to a little trick, by the way, but if you notice, the derivative of tangent, of the inverse of tangent, arctangent, well, notice it's 1 over secant squared, and secant squared is the derivative of its inverse tangent. The inverse of cosine, well, notice that when we get to the derivative down here, implicitly that is, where it's still with y, its sine, or negative sine, is the derivative of cosine, which is the inverse function of cosine inverse. And even with sine, way back here, if you notice a little pattern, the derivative of sine inverse, well, the inverse of sine inverse is sine, and the derivative of sine is cosine. And notice it was 1 over cosine of y. So implicitly, there's a little pattern here where it's just 1 over the derivative of its inverse function. All right? But to actually write the derivative, we want it in terms of x, not y here. So it's going to be 1 over secant squared of y. Now secant, a little trick is, remember that secant is 1 over cosine, and cosine is adjacent over hypotenuse. Well, since secant is the reciprocal of that, that means that secant is hypotenuse over adjacent. A little shortcut. So then hypotenuse over adjacent is going to give us square root of 1 plus x squared over 1. And then secant squared means all of this is squared. So what you end up getting here is 1 over 1 plus x squared. And there's the derivative of arctangent of x. Good. Now, technically there's the chain rule still, so let's look at an example with that, and then I'll get on to the very last one. So what if I did y equals arc sine, or inverse sine of 2x? What does that look like? So we would have that dy dx, if we were using what we had earlier, we know that from earlier when we did the derivative of sine inverse, we got 1 over the square root of 1 minus x squared. Now, how does that relate with an input that's not x? Because chain rule is always happening, right? So let's build into it. So I don't want to write dy dx yet. Let's sine both sides. And you'll get sine of y equals 2x. So if I make a right triangle, you have that an angle y, the opposite over the hypotenuse, is 2x, which implies that this side is going to equal a squared plus b squared equals c squared. So if I'm solving for this side, it'd be 1 minus 2x squared. So then, if I take the derivative of this, I'm going to have the derivative outside, which is cosine, leaving the inside alone, times the derivative inside, equal to 2. And notice what I get here is dy dx equals, if I divide this over, is it's actually 1 over cosine of y times 2. And I'm going to keep that outside for a reason, to help you see something. Which cosine of y in this palm is square root of 1 minus 2x squared, and then times 2. So there's your answer, but notice what it is relative to what we did with sine. So here's sine. So when sine was just x, it was 1 over 1 minus x squared. So notice that x, there's your inside right there, the x. Here the inside is 2x. Oh, I don't know if you can see that. The inside is 2x, and then because of chain rule, what's the derivative of 2x? 2, and that's where that 2 comes from. So you can see that the chain rule is always happening. So 1 minus 2x squared, or you can make that 1 minus 4x squared right away. Okay. All right, one more, and then you can do these yourself and get a feel for it, because again, you never know how you don't know if you know how to do it until you try it yourself. Watching me do it and following along with me is totally different than doing it yourself. You can watch a video on YouTube how to do something. It doesn't mean that it'll be that easy for you when you do it. Trust me, I tried it when it comes to a leak. It was a pain in the butt. Okay, example 5. Let's now look at y equals arc secant of x, the last one. Now, we would do it the same way we did all the other ones. So, well, a little trick here. We're not actually going to do it the same way as the other ones. Y equals secant of x, if we wanted to find the derivative of that, so dy, or d, how can I say this? Instead of looking at y equals secant of x, remember that secant is 1 over cosine. So cosine is adjacent over hypotenuse. Secant would be hypotenuse over adjacent. So we can actually rewrite this as y equals cosine inverse, or arc cosine of 1 over x. Because technically x is x over 1, and that again is hypotenuse over adjacent. So arc cosine, we just reverse those because cosine would be adjacent over hypotenuse. And now cosine we know how to do. The derivative of this function, and you could work it out with right triangles, but if you use what we had prior when we found it earlier in this video, it's going to be negative because it starts with a c. The derivatives of any trig function that starts with a c is a negative. Negative 1 over square root of 1 minus your input, which is 1 over x squared, and by chain rule times the derivative of your input 1 over x. Okay. So I kind of jumped to it from here from the fact that we already did this, or we built this generic formula earlier in the video. Now you can make a triangle here and do it if you want to. Now simplifying this, we have dy dx is equal to the derivative of 1 over x. Remember, you can write 1 over x as x to the negative 1 is going to be negative, and we have a negative in front, so I'll leave that negative in front. Negative 1 over x squared, because it would be negative x to the negative 2. And this is all over, if I start to simplify this, or I just write that as 1 minus 1 over x squared. I'm going to write it like this for a second. And then that I could write as positive 1, and then that x squared would go to the denominator, or you can think about it as this being over 1, multiplying by 1 over this times 1 over x squared, and you can see that the x squared is located in the denominator. So you get 1 over 1 minus 1 over x squared. Now this is correct. This is correct, but it's not the most common notation. And I want to make sure you see the algebra for that before I stop. So what's the most common notation is if we do some algebra manipulation, I'll show you in a second. So you have x squared, and if I write this as 1 minus 1 over x squared, well then I could do this as square root of x squared over x squared minus 1 over x squared. Okay. And I could write that as 1 over x squared square root of x squared minus 1 over x squared, which I could write that as 1 over x squared, the square root of the numerator, divided by the square root of the denominator. And then that I could write as 1 over x squared over the square root of x squared, all of that times square root of x squared minus 1. Okay. the x squared minus 1, make sure my math's all right. 1 minus, the 1 minus, I thought it was 1, yeah, that's right, okay. And then square root of x squared is x, but notice, so I'll just keep going a second more really quick, is that this right here would be x squared over x, and leave that x squared minus 1, which is 1 over x, square root of x squared minus 1. Now, because of the square root here, notice that if x was negative, a negative times a negative is positive, where the square root of that is positive, so you get a positive or a positive. So if x is negative, you still get a positive. And we have to adjust for that by adding a absolute value. So this is the most common way. So the derivative of secant of x, arc secant of x, is equal to, and I don't want to write dy because you don't know what y is, so I'll just write d dx. The derivative of this function with respect to x is equal to, the most common way they write it is 1 over the absolute value of x times the square root of x squared minus 1. And that's the most common. Okay, and I hope you can follow the algebra on how I got that. Right. So, what your goal by the end of this lesson, and it is just a one-day lesson, is that you hopefully can find the derivatives of all 6 inverse functions, all 6 inverse trig functions, and use the triangles to build into it until you get a hang of it. So if I started you off based off this video, and you'll want to do this yourself, the derivative of arc sine of x was found to be 1 over the square root of 1 minus x squared. I believe that's what we had, make sure, good. And then technically, I'm going to put this in parentheses, it would be times the derivative of the inside. All right, don't forget about the chain rule. The derivative of arc cosine of x is the same thing but negative because it's cosine, or it starts with a c is the trick there. So it'd be negative 1. 1 minus your input squared times the derivative of the input, or your inside. And then we had the derivative of arc tangent, or tangent inverse of x, is equal to 1 over 1 plus x squared times the derivative of the input. And then I also finally showed that the derivative of arc secant of x was equal to 1 over the absolute value of x squared minus 1. Okay. So your job is to get comfortable finding all those just like I did, find the last 2, and then if you might be wondering what's an application of this, that extra credit problem, of 80 and 84, I think combined, are a really neat application of how calculus and inverse trigs were used, or are used, to optimize the viewing angle there. Right? Sorry, it's a long video. Kind of a little bit longer math, but hopefully you're able to stick with me from beginning to end. All right. Good luck, and reach out to me or come to office hours if you need it. Bye-bye.